For this given circuit, I want to find the Norton equivalent circuit for terminal A and B. So essentially I have to find the short circuit current at AB. If I connect it, what is the short circuit current? ISC, like that. That's the Norton current. And then I will have to find the resistance, which I will do later. So let's do the short circuit one. Let's try to find it. So there is a voltage dependent current source here, and this is the control current which goes through the 4 ohms resistance. So I will apply node voltage method to solve this one. So basically there will be just one equation, this is the node here, and I can see there are this is one outgoing current and this current is I naught. So if I write KCL for this node basically, and the current through 4 ohms resistance is I naught, so the voltage drop across the 4 ohms resistance will be 4 I naught. So this point's voltage can be written as 4 I naught, given that I am assuming this one is 0 volts, this one is at ground. So I have let's write the outgoing currents. So first I have 2 amps, which is this one. Then I have I naught, because that current we know, I naught. Finally I need to find what is ISC, that's there. So ISC, first let's see what is ISC. ISC is the current that is going through the 2 ohms resistance, this one, same current. So the voltage at this point is, so here voltage is 0 because this one is short circuit, this one is 0 and this is short circuited. So voltage at this side is 0, and this point voltage will be, here it is 4 I naught, and as I go from here to this point I will encounter a drop of 10 I naught. So voltage at this point will be 4 I naught minus 10 I naught, that is minus 6 I naught. That will be the voltage here. So I can write that once, minus 6 I naught, that's the voltage, divided by 2 ohms, that will be the current, which is ISC. So I have that, all three currents as sum. I have written all the currents as outgoing current, and so this one has become negative because the voltage at this point is negative. So basically we can tell that if, depending on the value of the value of I naught, the current is probably coming in the other way, but let's see what we get as I naught. So we will need to solve this one. So that's 2 plus I naught here and minus 3 I naught, that's is equal to 0. So that one is 2 minus 2 I naught, which gives me I naught is equal to 1. So I naught is 1 ampere that I am getting here. So I need to find what is ISC. ISC will be minus 6 I naught divided by 2. So that will be minus 6 times 1 divided by 2, which is minus 3 amps. So that is the value of ISC. So ISC basically is going in that direction, not downwards. So when we write the Norton circuit, the ISC, instead of going upwards, it will go downwards, IN. So that's there. Now I need to find the value of the resistance of the Norton circuit. In order to do that, what I will do, I will make the sources inactive. So the current source will be open and the resistance stays there. The dependent source will be shorted out. So this one there. So I need to find the resistance that is seen from here. So this one here is 2 ohms and this is 4 ohms. So 2 ohms here, 4 ohms here. It's pretty straightforward. 4 and 2 are in series because this is open here. So Rn is 6 ohms. So here this is 6 ohms and In is equal to 3 amps. So this is the Norton circuit as seen for that terminal, basically AB.